Let's set the scene. You're about to uncover one of the most common and, frankly, one of the most destructive performance problems out there. It's a silent killer that loves to pop up in the dead of night, right when your system is about to buckle. And this quote from an engineer at Uber, it hits the nail on the head. In the massive, complex systems we build today, it's almost never one giant, obvious bug that takes everything down. Nope. It's usually a bunch of tiny, seemingly harmless things that snowball into a total catastrophe. You know that feeling, right? You're on call, it's 3 a.m., and suddenly your phone is blowing up. The alerts are firing. The dashboard is just a sea of red. Your P99 latency, that's the experience of your unluckiest 1% of users, it's just gone through the roof. For a whole lot of people, your app has just become unusable. And then, of course, the business feels it. Immediately, customer support tickets start pouring in. What started as a little bit of slowness is now a full-blown production outage. The pressure is on, and you have to find the cause, fast. Now here's where the mystery really begins. When you finally do the postmortem, you find out the trigger was a tiny, completely harmless-looking feature. It passed all the tests, got all the approvals. It wasn't a hardware failure. It wasn't some massive, obvious bug. It was something way, way more sneaky. So if it's not one of the usual suspects, what is this silent killer? What has the power to take a perfectly healthy system and just bring it to its knees? Well, it's time to meet the villain of our story. And that villain has a name, the N+1 query problem. So what on earth is it? Well, imagine you want to fetch, say, 100 authors from your database. That's your first query, the one. Then your code loops through every single one of those authors and makes a new query for each one to get the list of books they wrote. That's your N. In this case, 100 extra queries. So instead of one, maybe two efficient round trips to the database, you've just made 101. Now you're probably sitting there thinking, come on, I would never write code that inefficiently. And the truth is, you probably wouldn't, not on purpose. See, this problem often sneaks in disguised as your best friend, a real Trojan horse, and its main accomplice is the Object Relational Mapper, or ORM. These tools are amazing, but they have a default setting that is incredibly dangerous. And that dangerous behavior is called lazy loading. It sounds helpful, right? The ORM tries to be smart by not loading related data, like those books for an author, until the very second you ask for it. But when you ask for it inside of a loop, bam, you've accidentally triggered the N+1 pattern. The ORM is just doing what it was told, one query at a time. And the performance cost for that convenience is just staggering. Yeah, the term lazy loading sounds harmless, maybe even kind of efficient. But let me tell you, the true cost to your performance and your cloud bill is anything but. Just look at these numbers. Seriously, they tell the entire story. In a real-world test, the N+1 approach, that big red bar on the left, took a whopping 808 milliseconds to run. And the optimized approach on the right, 15 milliseconds. We are not talking about a tiny little improvement here. This is a night and day difference. That is a 54 times performance improvement. Just let that sink in. Imagine your page is loading 54 times faster just from fixing this one type of issue. This isn't some micro-optimization. This is a massive architectural win. And here's what it looks like. On the bad side, you have one request from your app that unleashes this absolute storm of individual queries on your database. It's just chaos. It's inefficient, and it creates a huge amount of unnecessary load. Now look at the good side. One clean request from the app, one clean response from the database. All the data you need in one efficient trip. This is our goal. And why does this matter so much right now? Because our systems are insanely complex. This quote from Uber really drives it home. A single tap in their app can ripple through 500 different microservices. An N+1 query in just one of those services can create a bottleneck that slows down the entire system, leading to exactly those cascade failures we talked about at the start. So the costs just compound fast. It's not just about one slow page. You're hammering your database, which increases latency for everybody. You're literally burning money on cloud spend to handle load that shouldn't even exist. And worst of all, you're building a fragile system where one little inefficiency can cause a site-wide meltdown. Okay, we've seen the crime scene, we've identified the culprit, so how do we fight back? This is the playbook that senior engineers use to hunt down, fix, and ultimately prevent the silent killer. All right, we've got three main weapons in our arsenal. First up is eager loading. This is like making a really detailed shopping list before you go to the store. You tell the ORM right from the start, hey, I'm going to need the authors and their books, so it fetches everything in one efficient trip, usually with a SQL join. Next, there's batch loading. Think of this like a delivery truck that bundles a bunch of individual packages heading to the same neighborhood into one trip. It's super clever. It groups all those little data requests into a single batch. This is the magic behind the popular data loader pattern. And finally, you've got good old caching. If you've already run an optimized query, why run it again? Just store the results and grab them from memory next time.
Now, fixing these queries when you find them is great, but you know what's even better than being a great firefighter? Preventing the fire from ever starting. So how do we build a system that just doesn't let these things get into production? The answer is a proactive defense. Here is your 4-step prevention plan. First, audit. Don't try to boil the ocean. Start with your most critical, highest traffic endpoints to get the biggest bang for your buck. Second, log. You can't fix what you can't see. Make every single SQL query visible in your development logs. Third, budget. Set a hard limit. Decide that a certain page should never make more than, say, 5 queries. And finally, step 4, test. Write automated tests that will actually fail the build if a code change goes over that query budget. This turns prevention into an automated safety net.
And that really brings us to the most important takeaway. Your ORM is an amazing, powerful tool, but it is not a magic wand. Every piece of convenience it gives you has a hidden cost. The real mark of a senior engineer is understanding that cost, knowing when a feature like lazy loading is a helpful shortcut, and knowing when it's a silent killer just waiting to strike. So I'll leave you with one final question. What N+1 queries are hiding in your code base right now?